All right. Well, I appreciate everybody coming in to this automation lunch and learn. And what I started doing with these is I wanted to start looking at the problems that people were having. And if I can make an automation lunch and learn out of problems that people are having, then it's out there for anybody to come in, watch some of these videos and see some things that come in. So I thought I would get more things out there and available like that. Every one of these, I want to cover the learning objectives that we're going to get in there. So this one, we're going to cover a little bit of the object-oriented programming and how we do things in VB.NET. We'll cover a little bit about the metrology.NET driver structures and why we do things in these multi-layers instead of wrapping all the code up into one piece of code. We'll talk about threading and debugging threaded applications. And then the big thing with this is going to be setting up Visual Studio. So there's some hoops you have to jump through when you're setting up Visual Studio with this. And we've been going through them with Aiden and Özcan, getting them all put together. So there's a few things you have to do with that. So a little bit about CalLab Solutions. So we do a lot of automation out there in the industry. Metrology.NET is our product. We brought that in, even though we have lots of MetCal procedures. We developed the PSCal. We discovered the industry and what you need to do in automation is changing. So we wanted to get those things put together in such a way that we could come in and solve the overall business problem that we have. Is we have to do things better, cheaper, and faster inside of the industry. So a lot of people get hung up on the cheaper and faster, but in metrology, it's also about doing things better. And over time, and that's the whole thing behind automation, is over time, we need to become more and more efficient. If we can't get rid of, or if we can't solve our efficiency problems out there, somebody's going to come in and solve them for us. And then pretty soon we're not an internal metrologist or we're working for a third-party Cal lab that business is going down. So this is something we have to do again and again and again. So I will start all of my lunch and learns talking about the problem statement. And one of the things I've discovered in software, and you guys will hear me say this again and again and again, but if the only tool you have in your toolbox is a hammer, then everything looks like a nail and you beat it to death. So a lot of people out there, they want to use the technology that they're most familiar with to come in and solve a problem. And I like to think of it as get a good problem statement put together. And from that problem statement, get it all hashed out what you need in your problem statement, then go looking for the right technology to solve that. So and the problem statement here is pretty small. So, but before you can do any testing, debugging, and development inside of metrology.net, you first have to get the Visual Studio environment set up correctly. So, and there's a few steps that you have to go through to do that. So our test requirements out here is we're going to have a 34401, and we're just going to test AC voltage for this example. We've already created the test package, so it's already available. We've already got the VISA scripts that we're going to use to control the unit under test, the 34401. We're going to use a 5730, and the 5730 I have here is actually configured to emulate a 5720, and I haven't hooked it up to see if this project's going to run with any errors. So this will be a true debugging problem today. So, and we've already created our driver, our source volts AC, and our test process has already been created. So we've already downloaded and installed the Visual Studio 2017 Community Edition. And for anybody out there, that Community Edition is absolutely free. So there's no cost to come in and actually start playing with things inside of metrology.net. You just need the Community Edition, and then you need the metrology.net DLLs that come with it. So the metrology.net library, and then the message service library. And then you also have to download install all the .NET Reactive. The .NET Reactive code that's on here, what that's going to do is that's going to allow us to do the multi-thread that's able to do in metrology.net. So one of the things we're able to do is run multiple calibrations at the same time on a single GPIB card. So we get a lot of efficiencies that way, and that's all done through the Microsoft's .NET Reactive libraries. So the first thing we have to do is we have to go in and set up a new project. And in Visual Studio, you're going to set that up to where your project is going to be a new blank project. It's going to be a new blank solution. And inside of that blank solution, you can add multiple projects. So one of the things you can do is if you're testing on the RF and microwave station, you can have an RF and microwave project put together for testing and something different for your DC and low. So you can have multiple solutions that's pulling different resources together that you can use to come in here and set that up. So you've got to select a new project, select other project types, and then select the Visual Studio solutions. So that's going to create the blank solution, and you want to navigate to C:_programming, ms.net, SASO, and then you're going to want to put it in your company name test code. And to give you guys an idea of what that looks like in the directory structure, you're going to see up here that we've got all these different companies in here that are doing things. So UMA, Spark, JM Test, got some images, CalLab Solutions, and 1ACal. These are all different companies. So you want to reach in here and put your data into your company. That way nobody else is messing with your data or your projects. So, and it's very important that you have this C:project or C:_programming MS SASO, because we have a references directory in there that we're going to keep everything in. So you want to make sure everybody in the group is using the same directory structure. Otherwise, all your references are going to become unsynced with your project, and then people are changing references, and you got to go back and re-reference your project every time you come in and do something. So then an important thing here is you have to set this to the .NET Framework 4.0. Okay, we do everything in the 4.0 framework because it's the framework that goes across the most operating systems. 4.5 framework will not install on an XP machine. So if you do any work in a 4.5 framework, you can't move that to legacy computers that are sitting out there. And I know IT is pushing us out to Windows 10, but we do have problems that we have some legacy computers that we have running that will only run with this legacy code, and we in metrology are fighting with IT not to take those items away. So once we get the solution set up, now we got to start coming in and adding more projects. So you can see under here underneath the solution, you can come in, add, and you can add an existing project. And we want to add into these directories, the SASO directory, when we want to add the CLS test code test point selector, we want to add that project in. Then we want to add our 57XOA project and our UUT command project. So what happens after we add those into our solution, you're going to see up here that we've got each one of those projects added into our solution. So we've got our 5700, our UUT testing, and our test point selectors are all added into our solution. So next, we're going to go in and create our testing solution. And you can name the testing solution anything you want to name your testing solutions. I typically name them by the computer that it's on, so that it's under CLS and then the name of the computer it's on, so I can quickly look at what's going on with it and say, oh, that's a testing solution on that computer. So you're going to come into the add a new project. You're going to set it to the 4.0 framework. If you set your solution to the 4.0 framework, then it will set all the projects you add under that solution to that framework. So that'll save you a little bit of time. So then you're going to come in and go down to Visual Basic. I like writing in VB. If you're a C# person, you can do it in C#. You can come down and select the classic desktop, and then you're going to come in here and select an empty project. So what an empty project does is it just gives you the core, and you don't have to go in there and undelete forms or take things out that you don't need. The downside is everything you need, you have to come back in and manually add to it. But we'll show you the steps of doing that. So then you're going to create the project in, and I chose, again, you need to be in this root namespace. Then you have your company name, test code, and then sample testing solutions. So this one was put in the CLS test code sample testing solutions. So once the project is created, the next thing we want to do is we want to click on the project, and we want to set it over here as a startup project. And what you'll see inside of Visual Studio when it's set as a startup project, you're going to see it become bold. So what that means is that startup project is going to be the code that the Visual Studio starts running things in. So it's going to start in that project and use all the references around it. Then we're also going to go into the properties, and we're going to set it to load submain. So now if I jump back to that, you get into the properties by right-clicking, going to properties, and now you can see here under application, I can set my startup. So I can set that to submain or AppMain. They're both equivalent inside of the code. So, and then the next thing I'm going to want to do is come in here and change it to an x86 project. And then we have that in here. So you have to come in and make it an x86 project. We compiled everything in the x86 because at the time, the Visual Studio we were using was not good for debugging in multi-threaded any CPU configurations. And so far, we've ran across 0 problems using this in x86 code. So we've just kept all of our projects in the x86 code. So now that we have the project set up, now we have to come in and start adding our references. So the first references, and this is why it's important that everybody keeps their code in the same directory, is we have this C:programming ms.net SASO references. And inside of there, we have our metrology.net and our message services. So we have to come into our project references and add those. Then we also need to come in and add our references that it's our .NET Reactive. The .NET Reactive core code is not standard in the 4.0 libraries, so we have to add them ourselves. So then we have to reach in and add into our references. We've got to add our 5700 project, our test point selector, and our UUT. So, and then we need to come in and add our system Windows forms because we want to have forms in this application. So we have to add our system forms. And now we've got all of our references in. So your system project with references should have all of these references in them. And if you open a project and it has a reference, but it has an exclamation point against it, that's because it can't load the reference from the directory that project is trying to look for it in. So jump into here real quick and I can show you that on the side. If I expand out my project and I expand out my references, you can see I have all of my references here. So that means all the references are ready to go. So next, we're going to come in and we're going to start adding some code. I typically start with an AppMain module, and then in the AppMain, I create a submain. Okay, and that just tells the compiler where it's going to go to start its code. So you go into your code, and to add things, you're just going to right-click in the project and add stuff. So real quickly in here, if I want to add something to the project, I can just go add. I can add a new item. I can add an existing item folder. I can add my references here. So I can add all of these different things right from this spot. So if I go add new item, it's going to come up and say, what do you want? Code, class, data. These are all the different things that you can add to it. So we want to select module, and we're going to create a new AppMain module. So down here, you're just going to write AppMain. So I'm going to hit cancel, and that's going to add this piece of code in here. Okay. So once we get the AppMain installed, the first thing we want to do is inside of our AppMain, this up here where it says imports. So in Visual Studio, whether you're in C# or in VB.NET or any of the languages, you're going to have these resources that you're going to use. And that's what the imports in VB does, or the includes in C# do, is they're going to say, I need to add these references into my code. So what happens is if you don't add these references into your code, then you have to type things out longhand to get them. So if you wanted to have this test form as new form, test selection, you would have to write out test point selector, form selection. So the imports allows you to have smaller code to say what you're using out of your references. So then what we need to do is create our sub main that's going to be in here. And then we're going to get in an array of arguments. So anytime something starts from the command, anytime an executable starts in Windows or in DOS, it has this array of strings that can be passed into it that you can use to control the program. So you always have to start with args with array of strings and return an integer. So here you can see that if I exited, I returned 0, which means everything was okay. And application exit, I just go ahead and close everything down. If I had an error, I return -1. And you can also put code in here to give the user some kind of information about what the error code was, or you can just exit. So then this code is going to call this test process code, and we're going to fill this out later. But this test process code is what's going to load up our test point selection form that allows us to come in and do our debugging. So the next thing we're going to add is our Fluke 5700 config, and we're going to do it exactly the same way. We're just going to call the name of the sub now Fluke 5700 config. And in this code, we're going to go in, and now we're going to import our 5700 series calibrator and our UUT test point controller. Then we're going to go in and create the instance of our 5700 that we're going to be talking to and our UUT. So you can see in my module 5700 config that I have a call for my UUT, and it is a test point controller, and it's going to be an address. I changed the address a minute ago. It's an address 01, and our 5700, we're going to call that, and it's going to be at address 15. So what we're doing, I'm going to jump ahead here real quick. What we're doing is we're creating these two drivers down here. So we're creating an instrument-specific driver for our 5700, and we're creating a specific driver that's going to handle our I/O to our device under test, which is our multimeter. So those are the first two drivers that we're going to create. So once we have those two drivers created, now we want to come in and we want to create our test process and our source volts AC. So our source volts AC code is going to come down and call our 5700 driver instance. And then that's going to get wrapped up into our test process source volts DC. So when we look at that inside of our code, what we want to do at this level in the code, which is our source volts AC, we might want to share that against different processes. So we can have a 5500 or 5700 that's going to source volts AC just straight up as a process. And then we might have another one that's going to source it and adjust the level of the output until the meter reads the correct value. So we get reuse of this, we get reuse of this, and we get reuse of this. The difference between a specific source and a specific test process is the test process is set up to go through multiple data points. So it's going to iterate through a list of data points, whereas the source driver is dealing with just one value, one process, one data point. So jump over here into the code, and I can show you that under the 5700. So when we look at the 5700 driver, you can see that for source volts AC, we've got a source volts AC. We've got a source volts AC where we adjust it. And we have a source volts AC where we characterize. So we hook the calibrator up to a 5790, collect all of its actual values. And now we can use the measured value off our 5700s, where we're really using a 5790 to calibrate the device under test. But when we look at our level 2 of the drivers, you can see we only have one source volts AC driver. So that allows us to reuse that source volts AC driver again and again and again. So that's why we structure the drivers out the way we do. And at the end of the day, it's just a coding preference. So now the last thing we're going to do inside of that code, inside of our test code, is we're going to come in here and we're going to get all of our test processes. And you see we're getting back a list of test processes. And all we're doing is adding the test processes to it. So if I want to add volts DC, I can go in and add all my volts DC and add it to my test process. Then we go back into our main code, and now we set that test process in our form. So we grab out our test processes from our 5700 config. It comes into a list, and then we add our test processes to our form. So that says with this form, now we're going to use these test processes for configuration. So this allows us to have configuration 1 for station 1, configuration 2 for station 2, but we get to use the same core code for running our test processes. So then when we come in and create it, this is what we're going to see when we compile. So I'm going to grab this, move it out of the way here, pull this up. So now you can come into my code, get my code up, and now you can come in and see my configuration. So here's my 5700 driver. So here's this AppMain that we were talking about. And here I have these, the 5700 config, and you can see I can right click on this and I can go right to my definition. So this is that top where I have my list of test processes, and here's my source volts AC. I can right click on here, go to that definition. I can look at my process, see I have my source volts AC driver. I can right click on this and go to my definition. Here's my reference to my source volts AC driver, my second level of my driver. And I want you guys to notice this keyword here, static source. And you see how I say if it's nothing, then I'm going to create it and add it to my source. What that static keyword does in Visual Basic is it tells it only wants to create one instance of that, and it's going to keep it every time the function is called. So the first time I call the function, the source is nothing, so I create it. So the second time I call it, it's only going to give me that one pointer to that device. And that's how we want to keep our drivers configured. Because if we create two source volts ACs, then we're going to have two drivers trying to do the work, and they'll conflict with each other. So now I want to look down to my driver instance, and I right-click this, and I go to my definition. And here I can see I've got my driver configured. Again, my instrument is only created once, and it's going to be at address 15. Typically, I like to come in, open my NI, and do a scan. You're not limited to just the National Instruments cards. We support the IoTech and the Keysight cards. So you can use any cards out there that you like as long as they're Visa compliant. So then you can see here I changed my address to 01. So now we should be ready to go. So it's doing a quick compile. You can see down here where it's compiling everything up. So now it's loaded up my test form. And the way my test form works is now I can log into the server that I want to do my testing on. Log in. And it goes in and grabs me all the work orders that are assigned to my workstation. So now I can click through each one of these work orders and see what's going on. If I needed to go in and modify a work order, so if I needed to go in and add a work order to this, I don't have to restart the form. All I have to do is hit the refresh button. And that'll refresh it and bring me back that form. So here we want to test the 34401. And because I want to come in and test things, I'm going to come in and figure out where my solution went.
Tab on the right.
Yeah, so now it's up here. So I'm going to come in to, actually what I can do is I can go this way. This is actually a better way to go. I can right click on this and say go to definition. And that'll bring me right into my code. And then I can scroll down into my code to my run, and I can put a breakpoint. So one thing you have to remember is you see how this breakpoint came up in red? If it comes up with a red circle around a white dot, that means the code is not synchronized, so it won't stop. So now if I come in here, I click on the volts AC and I hit run, you're going to see it's going to grab that process and it's going to start running it. Any second now. So now you can see I'm into that code. So it called up the run function. So real quick, I'll jump over here. Oh, actually, I don't have that out there. So I should add a slide in here that's talking about what it's doing between there. So what it did when you said you wanted to run this process is it went to the server and it grabbed all the data points for that process. And now I have a bunch of data points that's available for me. So I have all the data points for that test group inside of my test points. So this piece of code here is going to go out and it's going to load the Visa script. If I wanted to put a breakpoint to where it's loading the Visa script, I can come back to my AppMain, go into my Get My Process, and I need to keep this open. So if I come down here to my unit under test where I've got my Visa script, I can go to definition. And then this is going to call the setup function here that's going to download the test. So you see how we got set test group? So now when I come back, so this little arrow here will take me back to my next statement. So this is the next statement that's going to execute. If I step over this, you're going to see it stopped at that code, and now it's going to download that. So I can unconnect that, hit continue, and it's going to come back to my main thread. Okay, this version doesn't come back to my main thread. So give me 1 second to get back to it. So I'll put a breakpoint there. And now what I'm going to do is pull up the interface. And if I come to my work orders, I can see that my 34401 now needs assistance. And I can click on that. And now it's asking me to set some things. So it wants me to set my visa address. So GPIB 0, hit enter. And then I can set the number of readings I want to take per run. We're going to leave them at 1. But if somebody was doing a 17025 cal, they could set it to 5 or 10 or whatever they want to run. Hit continue. Move that out of the way. And here in a second, you'll see it'll come back, reset my devices, and should stop on this breakpoint. Boy, are we running slow today. So now it reset my AC source and it reset my unit under test. So now I'm at this filter. So if I right click on this filter and I go to the definition, you're going to see here that we're going to exclude any data points that are less than a millivolt or greater than 1100 volts, and any frequencies that are less than 9.5 or greater than 1E6. So we're just going to exclude those data points. So we're not trying to calibrate something that's outside the range of our calibrator. Again, we can come back into this, and this will bring us back into where we're executing. So now if I want to do a UUT, so I want to do a source setup. So I'm going to put a breakpoint here. And then what I want to do is jump over to my 5700 code and put a breakpoint in there. And we can see what it does when it's setting up the calibrator. So there's my reset function. So here's my setup, my calibrator. So here I'm going to put in my breakpoint, go back to my definition, and I'm going to go ahead and hit continue. What you're going to see it doing in between there and now, if I can bring this over, is now you can see that it's given me my connection message. So scroll down, hit continue. So that's going to be what it's doing in this chunk of code here. Now it's going to set up my UUT. So now I'm in my setup of my sub. So inside of here, this is going to be a step over. So I'm going to say, hey, do you have a frequency? If I have a frequency, get it. If not, return, you didn't provide me a frequency. Then I'm going to check the limits of my frequency. Then I'm going to come into my volts and say, did you give me a volts? Yes. If not, throw an error. Then I'm going to check the range of my volts and see that my volts has to be in range. So then I'm going to come in and check some boost amplifier things and set up a boost amplifier if I need it. So now I'm going to set in my subdriver, the actual instrument driver, I'm going to set the mode to AC voltage, the frequency and the voltage. And what I'll do is jump back in here and dig into our 5700 driver. And under the enable output is where you're going to see all the pieces parts happen. So I'll put a breakpoint there, come back into my main code, take away this breakpoint so I don't get stuck on it next time, hit continue. And now you can see that we did all of that setup work and we came back in here. And one of the things I like about the newer versions is it'll actually tell me the elapsed time it took to do that operation. So it seemed like it was slow, but it was really the UI that had to catch up because it only took, well, actually that would be 10 seconds because I was stopping in the code, but it'll show you the time it takes to run through those functions. so you can come in and look at the different things that you're running inside of your code. So now we're going to check our status code. We were good. We're going to enable our output. So now you see that we're under that enable. So here's where we look at the modes and we say, hey, I'm AC volts. So here's the command I need to send out to do it. If I want to see what that command looks like, I can reach into my watch window and I can grab that whole chunk of code and throw it down here. And that'll show me the exact command I'm looking at. If I wanted to check it with the I/O, I can start up my I/O trace and I can look at it there, start that. And now you can see as I step over it, it set my calibrator up. And now you can see it actually sent what command it sent out. I want to go in here and go to a different point and set another breakpoint. So now that the calibrator's set up, so we'll come in here and talk a little bit about test results. And I can just hit continue. So now what it's done is it's checked, hey, can I do the test? I didn't get a status code. Can I turn my output on? Didn't get a status code, and I can look at the different messages and give them up. So now I want to start doing my test result. So I'm going to create a test result, and this little loop here is going to look at the number of readings. So we're only going to take one reading with each one of these data points. So now you can see that I'm going to come in here, I'm going to measure my result on my unit under test. It pulled back my result. I'm going to check the flag to make sure there's no problem. This was the measurement that came back on my unit under test. This piece of code right here, AC volts measure and, is going to go get the measurement uncertainty. So now I've got my measurement uncertainty associated with my test results. So now I'm going to save my test result. So this puts the test result up on the database. And now if we come over to the database, now if we come over to our AC volts and we do a refresh, we can see that our data point has been pushed up there. So as a 10 millivolts data point with an uncertainty of 4.8 E minus 6. So that's in a nutshell how we come in and run and check our calibrations. So wherever I want to put a breakpoint, I can put a breakpoint in the code and see what's going on. So we'll limit this breakpoint now back into, I want to look at the next save results, and I'll hit continue. Now, one of the things that you'll notice is the system will run slower when it's in debug mode because it's holding all of those things and keeping track of all of those threads and all the breakpoints. So that's one of the things you will notice as you're testing your code in debug mode is that it will run a bit slower. All right, so this time we should have our data point back. And we do. So we measured 100 millivolts this time. So now we can sit back and say, I don't want any more breakpoints, just continue running the code. And while we're sitting here answering questions, it'll keep running code. So I think we covered all of our learning objectives in here. So we covered some of the object-oriented programming, a little bit about how we structure the drivers. If you got a copy of metrology.net and you come to one of our training courses, we will go into this into great detail. So we talked a little bit about how you step through threading applications. If you do a step into one of these driver calls between things, so if you do a step into this call, you're not going to be able to step into the call to this driver because they run on different threads. So that's one of the things about making the application fully threaded, that you have to put the breakpoints at the place you want to stop, and then do a step over the code and it will get to it. So other learning objectives, how to set up Visual Studio to do metrology.net testing. I think we covered that one. So I will open it up for questions.
Mike, should we put what you just made on GitHub? People can grab that example.
Yeah. That process is available. That test process or that testing solution I created is available on GitHub.
Yes. Michael, can you share the recording with us?
Yeah. So if you go to CalLab Solutions, you'll see that there's Lunch and Learns. And every Lunch and Learn we do, we publish it out. It usually takes me about 3 days. So, but
Okay,
the presentation will be there and the video.
Okay, thank you.
I've got a question, Mike, and I've probably asked you this before. How are the images stored into the drivers?
Okay, that's actually a real good question. So,
because I see you have like a little connection message that shows you how to hook it up. If I wanted to design something for a test process that I'm creating, I'd like to be able to know how to do that.
Yep. So the way we put them in is you're going to have a resources. So when we pull the resource up, this is going to be our PNG file.
Right.
Okay. And then what we do is you give it a name. And if you right click this and go to properties, you're going to see that it's an embedded resource. So what that does is it takes the picture, the BMP file, and literally puts it right in that DLL so that you don't have to manage files like you did at Metcal and name your pick right and get it in the right directory.
Right.
Yeah, so it puts it right inside of that DLL. And then at the top of the program, you're going to see this creation. So you see how we have this add connection state? So call it this is going to be our name. So when we come down in our code, we're going to say this is the connection state we want it in. Then when we go to our connection state and right click this, that we're going to give that connection state a unique ID. And then you see here where it's got user embedded pick. That's the actual name of the embedded pick. So that will reach out, grab that code, and it will basically serialize it up to the server so that the server knows how to present that picture to the user.
Okay.
So, and if I get back, I don't have this Visual Studio set up like my other, so I can't get to things as quick. But now if we go back to, that's the actual pick that we were giving it was the 5700 2-wire PNG. So that's the actual pick that will sit in there. Now, to create the picks, you can use anything you want. We use a tool out there called, that was put out by Microsoft, the Designer tool. But if I open this up, so Expressions Designer 4, it's a free vector graphic tool. So what happened, these guys are vector graphics. So when I scale them out, they keep their size. None of these are good examples. So here's my 5700. When I scale that, you see how everything stays in place? It's because all of those things are connected together. So the vector graphic allows me to size the connection to where it can be more presentable. And then we're doing all of our connections in 640 by 480 is what we decided as the size of the picture. Any other questions? All right, I'd like to thank you all for making it.
All right, thank you, Mike.
Thank you, Mike.